Hi, Anshuman. Welcome to my video chat series.
Thank you.
We've been
Thank you for having
go ahead.
Thank you for having me. Yeah, I'm excited to be here and talk to you about this.
Yeah, we've been friends since ISEC days. Like it's been a decade, and who knew? Like now is when we'll have so much work talk also. Which is last 6 months we've been really like on and off with so many things. You're like my go-to person for so much that is fact, what is fiction. Because people tell me all kind of stuff when they're like talking to me about AI, and I'm like, Anshuman, is this right or wrong? So it's good to find.
Yeah, no, there's a lot of information out there, so I try to see what I can pick up and learn about new things. So yeah, it is hard to keep track of with all the new innovation happening, and the best way to learn, I think, is from other people. I learn from so many other people that I follow or can chat with. So totally, yeah, I'm glad that we've like sort of caught up again after our ISEC days and now able to talk about AI. And who knew we would be doing this?
Before we jump into what we want to discuss, which is the federated learning, can I still ask you how these CDNs are they even prepared for the agentic network? Like, if websites were to be now, like agents were to show up on my behalf, are these CDN networks also ready for that information? This is just one, I know it's a digressive question, but I still want to ask you, considering you have some knowledge on CDN.
Yeah. So for people who don't know what CDN means, it's a content delivery network. It was for a long time the backbone of the internet, way before cloud computing existed. But yes, the whole idea of CDN is the last mile delivery of any content, any digital content, I should say. And you want to cache any kind of like static website assets or video content closer to the consumer. That was the whole idea behind CDNs. And then over time, I think cloud computing became more, I guess, consumed, and the nature of front end applications changed. It went from like static website pages to single page applications, and more design started happening on the cloud rather than the CDN. But I do think in the AI inferencing age, CDN has a role to play because you would want to do edge inferencing, which if you just do cloud-based inferencing, you need to go to some centralized location, make your predictions, then come back and then serve that to the customer or your end user. And that is going to take or add latency. So I think CDN has a space where you can maybe distribute. This is just conjecture. I mean, I know CDN companies are doing a lot. You've seen all the big players come up with some sort of solutions, and they're partnering with GPU providers to build out this capability. But I think the future is where you would have GPUs distributed closer to the end users, and then some version of these models run at the edge. And they're able to make predictions way faster, latency would be, I think, in the next couple of years, latency would go down if CDNs are sort of the backbone of AI inferencing. That's just my conjecture. We'll see if there's some new technology or CDNs just morph into something else, or they might combine cloud with the CDN to build like a totally distributed network. So I know a lot of companies are working on this idea right now.
Yeah, because like the internet was largely designed for humans to interact with information, and you know this change at which people are building agents to crawl over the web and all. We're not. I don't know how much we're ready with the infra to enable it. Is why I was asking. Like, agentic commerce companies are getting funded, and even the browsers of these frontier labs and stuff are taking over. So I was just asking from the infra level, how far are we? But you're saying then the companies will also step up that are doing that work.
Yeah, it's not a complete redesign of the internet architecture. I think there are elements that we've already built that can be repurposed, but new elements do have to be built. Like, how do you really distribute GPU load at, at the edge? That is hard because GPU data centers tend to be not as distributed as a CDN network, right? So maybe you can have lightweight GPUs at the edge, and then you have like these mega data GPU data centers in one location, US East Coast or something like that. But in terms of just human versus agentic interactions, I think there you're going to see. I think it's more of a front end or a UI experience that, yeah, we've been designing applications from human perspective, but now when agents need to just take actions on your behalf, in many cases that seems to be easier in my eyes, because you don't have to think about all the different visual elements that humans have to click to. You could just maybe build it more I don't know, programmatic, or just some kind of API interface that the agents would interact with. So CDNs and cloud is very well designed to sort of interact in or work in that environment. Yeah, that's my opinion.
Yeah, sometimes I think from UI perspective also, as simple as a markdown file is sometimes sufficient for the agent to finish work, versus for humans, we don't read the whole thing. So then the websites have to have graphics and stuff. So same
Correct.
page. Which brings me to the federated learning part. I was asking you, is personal learning the best use case? Because the model can take a really long time to learn about me. And I, as a human, have not, and now I've been trained for instant gratification, right? Like everyone just gets me so quickly on ChatGPT and Instagram that do I really have the patience of 2 weeks, 4 weeks for the model to give me the best output it could give?
Yeah. So just want to level set on the definition of federated learning. I think there are multiple flavors of it. The version that I'm most familiar with is in the deep learning context, where you have uh, a centralized model. Have you seen Stranger Things? I'm just curious. You've not seen, okay. I had a very great analogy with Stranger Things. Anyway, I'll skip that part. Yeah, there is a centralized model, and then you have a bunch of distributed nodes. And each of these nodes have smaller parameter models that then send the parameters to the centralized model. And then the centralized model learns from those parameters and basically fuses information from all of these edge devices and builds a more robust model. And then it pushes the predictions out back to these smaller edge devices or your end nodes. So there are other flavors of federated learning as well in the non-deep learning context. I know in statistical learning and traditional machine learning, there are other ways people do it. And typically, I've seen the use cases for federated learning are around data privacy. That is usually where you would want to consider using federated learning. Um, Healthcare is one of the best examples for that. You don't want to share your confidential patient data in some centralized database all the time because that is prone to attacks and that can expose your personal information. In the context of personal learning, yeah, that's an interesting use case. I've not yet seen any end-to-end application of that, but you could argue a case where you have this one centralized model that learns a bunch of different tasks and then it learns from your specific data. So you could, instead of sending all your data over the network to a central data center or central model provider, you're basically sending model weights, right? So some sort of like it does local learning and then sends it over, and then that central model learns from your data and then pushes predictions back to you. So it is, I think, depending on how you implement it, the latency could be a factor or it could not be a factor. Yeah, if you're waiting for the model parameters to sync and then get a prediction, yes, latency is going to be a lot. But if just in a off policy schedule, when you're not using your device, the model is syncing with the centralized your local model is syncing with the centralized model, then it doesn't really matter because what matters is inference latency, right? At the end of the day, that as as long as you can predict for a given task that you're asking as quick as possible, it it doesn't matter that the federated learning paradigm is going to take a longer time. But the use cases of doing this are very, in my eyes, right now limited because you can do things with batch processing really well. You don't really need federated learning all the time in the recommendation engines, for
But
example,
I
if you
was
just
going to ask you not from speed. I was saying the quality. So if my model learns only from my data, it would take a really long time for it to be able to give me the quality of response. Because I'm also, there is only limited data on my phone, right? It's learning from very small training data set. I'm asking from that perspective, would it be as helpful as some model which has the LLM? information and data, sorry, plus my context as RAG or memory. I'm saying it's still personal learning with LLM plus my memory makes just as much sense. I'm trying to understand like what's the differentiate besides data privacy. Oh,
Yeah, so you're still learning from a bigger model. So you're not like reducing the model size by just using a device. What is happening is local version of your model, which is trained on your data, is being synced back to a centralized model. And that centralized model is taking those smaller parameter weights and then updating its weights so that it can learn from diverse interactions people are having. So it is, and then it's sending that information sort of back to these smaller models when you're doing predictions. So you're not sort of losing any performance per se. I mean, at least that's what I know about federated learning. There might be cases where yes, a model performance does degrade. So yeah, does that help or
yeah, yeah,
answer
it
your
helps.
question?
Yeah, but because I only gave you federated learning as a piece, when I was interviewing my last guest, he's doing decentralized federated learning models and a small language
Okay.
model, which is why I'd called you to understand some nuances about it. So just federated learning, yeah, this answers my question. If it
Yeah. So
was,
if you were to train a model from scratch using this, so there are training paradigms that also rely on, okay, we don't have centralized data, pre-training data available. So we need to learn on the fly and collect data from devices and then build a model. That is a much harder task because there,
yeah,
yes, you don't really know whether you have good quality data. I mean, you need to do a lot of extra engineering effort to make sure. And you need, yes, just like in pre-training, you have all the scaling laws. You need to use that information to know how much pre-training data you would need. In federated learning, that might get much harder because you don't know how many people might sign up or how many users you have, right? So yeah, it's a harder problem.
yeah, it's harder to scale also. I get it. That's what I was asking.
Yeah, I think that's why you've not seen federated learning used because I think the paradigm has existed for more than 10 years. If I like, if you read the first paper, probably it's more than 10 years.
Google did for keyboard in 2016. That's also I'm told. Yeah.
Right. Yeah. Yeah. So it seems like batch, you get everything with batch processing that you don't, they're very limited. I think data privacy is the number one reason why you would use federated learning. At least that's what I think. And there are some newer things that people have invented, like homomorphic encryption, that would even, negate the use of federated learning. You could just use encryption as a way to train your model. Or homomorphic encryption is like it's a very niche research area right now. I've not seen like large scale use case of that, but you could just encrypt your data, send it to a centralized server, and then the models can learn from encrypted data, which is very fascinating because if the data is encrypted, how is it able to update the parameters? So there are that if that paradigm works, then you would technically not even need federated learning. But I think we've not yet figured out how that should work, or homomorphic encryption with deep learning would work. It's pretty slow. So yeah, or you could combine it with federated learning too. If some people have tried that, I'm not quite aware, but yeah.
And like the thing we were talking about memory, I don't know. I know people are still trying to solve it in so many different ways. So every founder I talk to says memory is their problem. Every startup founder that's building in AI, some are trying to solve the context in RAG, some are trying to innovate. But like I've not kept myself very updated. Where are we on memory right now? Like who's been able to solve what so far? Besides the usual open AI saving some context and stuff like that.
Yeah, memory is a hard problem because keeping
Everyone's
all
telling
of,
me, whoever I talk.
yeah, I think my sort of opinion on on this is that we need to invent something else to solve the memory issue. If you think about the human brain, I think we've discovered parts of it through neural networks and our current large language models, but how true memory works or how causal reasoning works in human brains, that is yet to be discovered. I don't think just storing information, in some sort of like RAM or context engine or RAG is going to solve that because you can have countless amounts of information that you could store and what to store is hard and how long to store it. I think right now people are probably approaching it from the OS operating systems perspective and how we've designed operating systems and memory in operating systems. I think similar concepts are creeping in into agentic memory and LLMs, but I think there is something else. I don't know what that is. I'm not a neuroscientist. They would probably have better answers.
But you did tell me that, like, and I agree to it. The next innovation on memory has to come from the intersection of neurobiology and, like, I don't think it's just a software problem. I don't think it's just an engineering problem.
Yeah, no, there's more hardcore research needed on this space. On, yeah, can we learn from neuroscience and see? I mean, even like if you think about deep neural networks, if I have to teach just even mice to detect something, you don't have to show it a million images of something and then it learns it. You can learn it from pretty few images. Like that's how humans also learn. So there's something missing fundamentally in our entire research pipeline and how neural networks work. But yeah, neuroscientists would know what we are missing and what we should work on. But codifying that into math that we can replicate, I think that has not happened yet, and or we don't know how to do that. And I'm sure people are trying across the world, but yeah, so it's a hard challenge.
Yeah, because at some point, right, I have been able to get the best out of Claude as an LLM, I would feel, after 2 years of working with it, 1.5 year now.
Hmm.
I still feel like, man, it really needs so much memory or remembrance every time. Like,
Yeah.
if I move from one project to another, it's gone. Again, I have to restart. It's almost like operating in folders, but human brain does not operate in
No.
folders, right? Like, I spoke to you, but if I speak to someone else about ice cream, I still remember this conversation as context,
Hmm.
right?
Yeah.
I don't. So this is why I think Richard said the whole LLM. He also said because there's no real world interaction, but I meant like the LLMs have a certain threshold.
Yeah. And also, if you think about it, memory sort of has a relationship to reasoning. What conversation you have in one sort of folder, as you're saying, or yeah, one chat history, you can use that to learn patterns that would be applicable in other areas. So, it can't just be next token prediction or you fine tuned it to answer it in certain ways. We need a way to do, and I think researchers are now thinking about this continual learning, and they are going more into that direction where yeah, from can you use smaller models to continuously learn from what you have and how you've interacted with the world? It's sort of different from reinforcement learning because it is not necessarily a reward model being used for continual learning. There are different algorithms that people are trying. But I feel there is a connection with agent memory and continual learning. That your memory is not just this fact database that you're using, then based on that responding. There has to be some causal reasoning tied with what you've learned or what interactions you've had so far. And that should then maybe lower your storage requirements for memory. Human brains don't, we can't store that many facts if you think of our own brain. Yet we are able to do tasks like driving just involuntary. It just once you learn it just happens on its own, and I think there is some gap between how that happens in human beings versus how we're approaching the agentic memory.
Yeah, but for this, the LLM, so how I've understood this also, I'm also not like in pathology or neurology, but like there's an experience that happens. Of course, the brain kind of, when we sleep, consolidates that info, probably bunches it into like some categories, and we forget that experience probably. 10 years later, if I remember something that would remind me of this experience, I reconstruct that memory. So,
Mhm.
which is why we're so efficient, right? As a human brain, we don't store everything. But I will remember seventh class X exam, I got 99%, and yet I felt very bad. Only when an
Mhm.
experience like that happens at work where I got an award and whatever. So the brain has this way to connect to thoughts and map it with that reconstruction at some point. I don't think right now, of course, it's happening, but only when that reconstruction capabilities come can memory really be solid. Otherwise, you have to remember everything. Like there's database management everywhere.
Yeah, What you just described, that is what is not yet figured out, or like how do we take that concept and codify it into math that we can then use in these models? I don't think anyone has a good answer to that. I know people are trying with continual learning, and there are some other areas of research that people are looking at, but it's an open-ended problem right now. But yeah, I agree. Just using some sort of a database system to solve the memory issue, I mean, it'll help. It definitely helps, but there's only so much you can get from it. After a while, you're going to see diminishing returns, and I feel that's what's happening with the current coding assistants. I feel the same way that when I'm asking it to do something in one file and then switch over to another file, it just forgets sometimes, or you spew some random thing. So that problem is still not solved, at least from my perspective. There is the
And
argument that the more data you show it on one task, it gets better, and so then that is another area that people have seen or yeah tried to tackle that problem. That give it more specialized data, and that maybe will solve some of the memory issue.
And the reason I bring this up, what you just said, is LLM is novel right now. We're still experimenting it. But after 5 years, 10 years of our database with it, it'll be very frustrating if it is asking us the same question after 10 years of interaction. I hope it doesn't happen that way, but I see that happening because of the wall that it keeps hitting. And every time the context tokens are over, I have to restart the chat. And it is a frustrating experience, which is why I'm bringing that up, that it's still 1 year
Hmm.
of with Claude. When it has 10 years of information across 100 million users, that's like a
Yeah.
lot.
Yeah, it's a very hard engineering problem. I mean, for Anthropic and for these AI labs, I think that's why they're investing so much in AI inferencing infrastructure, because that is a much harder problem than just doing pre-training. Is you're done, you do once, build the model, you're done, right? And then you have a lot more to do in terms of like getting the model to be useful. It seems like the more harder task right now is how do you scale it to millions of users and billions of users at some point. And yeah, so it's much harder engineering task, and that's why you need so much compute to do this kind of work. Yeah.
Would the models, whatever information they generate, learn from that as well? Like, I'm asking this from the point where everyone on the internet is saying the training data is exhausted, internet speed kind of be done. Like, everything now that's getting generated is mostly AI generated in some form or
Hmm.
the other. So have we really exhausted data, or models can keep learning from their own output? Not from the RL perspective, whatever new data gets generated.
Yeah, so synthetic data generation is definitely being used to train these models. Are there is a lot of sort of debate whether continuing with synthetic data is the right approach, because you can end up in this model collapse where what it's generating is being used to train, that sort of it kind of gets stuck in similar kind of data patterns, able to learn new data patterns. So, and there's wonderful research done in the space that explains all the pitfalls of using synthetic data for training, and when you can actually use synthetic data for training, because there are cases where it actually really helps. You don't need
Like,
that. I think a lot of like self-driving cars is one example I can think of. Synthetic data is very useful in those kind of situations. I think text data is harder with synthetic data because yeah, you need to verify the quality of the text being fed. I think LLM providers use in their data pipelines for pre-training, they have a lot of tools and checks and secret sources that they're using to make sure the data they're using has good quality for pre-training. But even for fine-tuning, like self-driving cars is one of the best examples where synthetic data is useful. At least I've seen. But even with synthetic data, it's so hard to get a full real-world self-driving cars. Is just because there's n number of situations that can arise that you can no longer generate synthetically. But maybe with the world models, that will get better, where the AI is interacting more and more with the world and then learning, okay, these patterns I need to make better decisions. So I think synthetic data has a bright future in the text domain. How long we can continue, I'm not quite sure because yes, you can end up with model collapse, and that's something researchers are worried about going forward. So I think maybe we'll see the research direction go into, oh, can we shrink the model sizes and then do some sort of continual learning to get more efficient from these models? I think scaling will help only to a certain extent. I think now we're going to see ish. This is my prediction that maybe in the next 20 years, researchers will try and shift back to smaller models. And can you do more continuous learning than just keep making larger and larger models?
How do you define world model since you brought it up, but like I don't think the audience would know. So maybe you want to just take a minute to explain
Yeah,
it.
I don't have a right definition. I think I just like in passing seen what models are and what people. I think different people have.
So the self-driving car itself, I think example would help.
I think as I understand, world models are trying to infuse all modalities. So it could be text, speech, images, video, and trying to create some sort of a framework where the AI can learn from interactions in like a world, or it could be just similar. Yeah, it is a simulation of some sort where the AI can interact with and learn. So that is
Similar to
what.
AlphaGo. AlphaGo.
So those are not really. I won't call them. I guess they are initial, not AlphaFold, but AlphaGo could be considered as a initial version of world model, but they were only using one modality, which is the video of playing games or AlphaGo. But I think you're going to start seeing all modalities being fused together. I think some of the latest Google video models, they are trying to use those video models to generate data where the AI can interact with it and then learn from it. So that's one. I know Meta has announced that they are going to do something similar with in their direction of world models, create simulated environments, learn from them. And to be honest, this paradigm has existed for a very long time, like
Yeah,
in
video
operations.
games, right, Anshuman? Video games where I'm not saying they use world model, but it would render only once it interacts with the user, right? Like the rest, the next game or the next stage or the next scene renders only
Right.
once I interact.
Yeah, but like I mean, in video games, things are deterministically determined, predefined, right? Like you're pre-coding. Okay, yeah, this is your environment. This is how your player interacts. These are rules. World models are slightly different. I think there's more of this exploration. So you're kind of bringing in the reinforcement learning aspect into it, where maybe you're taking an action, something worked, so now you got a reward, or something didn't work, you got a negative consequence from that, and go from there. So I think in operations research, which is my background, simulation has been used in a variety of instances. And this kind of concept is not new in the OR space because people have built simulation environments. Let's say you wanted to understand traffic patterns on an interstate highway and what are bottlenecks. So you would create a simulated world of your intersection highways and see, you know, like introduce some sort of stochasticity into the system and see how different players react, and then from that you kind of learn something useful about the dynamics of the system and model that. So that kind of modeling has existed. Now I think now it's the exciting part with world models is how it's going to fuse all these different modalities. So yeah, it'll be very power hungry and very GPU hungry, but I think that some interesting research is going to come out of the world model paradigm. Sure.
So I think about it a lot, so I thought I'll ask you. How does a model get its identity? Is it like through its weight or personality or prompts? Like, how do you identify a model? Like, they call it Opus and Sonet and whatnot, O3 and all, but
Uh-huh.
like how we have a identity, right? Like models, how do you define the identity?
Yeah, it's an interesting question. I've never thought about that question myself. I mean, I would think that these models are imitations of the humans that they've learned from, and so they are sort of an average of the human interaction that they're trained on, and that's their identity, I guess, in a way. And different models have sort of different, somewhat differing data that they're trained on. So, you can see these differences maybe on how Google models tend to respond or how Anthropic's model tends to respond. Yeah, I don't know. It's not a question I've thought about.
Let's just try to brainstorm. If it's the same model, but they just tweak the weights, let's say.
Okay.
One element changes, the identity does change, right? So it's not the sum total of. I'm just trying to I've thought about what you've said, which is, whoever
Yeah.
trains it, they get the identity of some average of that particular data set or human set. But it's
Yes.
not that simple. Same model, five different people tweaking.
It's not it's not really the same model because all of these providers have different architectures that they're doing. So if you say yes, it's the same approach, everyone has the sort of the same approach. But it is still different from how the data, how they're utilizing the data, right? So I think it is an average of the data. I think your point is if the approach is same, why are they not similar in identity just because they're different in weights? Is that where our thought process is?
Yeah. Yeah. Because if you take Llama, which is open source, then everyone who's building on it that output is different, right? And so I'm just trying to, maybe there is no answer to this. I said it's a
Yeah.
philosophical question, but like, how if tomorrow people are trying to make these models as close to how humans behave and think and do, then what the question about the identity does come into picture, right? And in
Yeah.
movies they give very simple names and all, but it's not that simple.
Yeah, I mean, to me, it is still a reflection of how that team decided or that company decided to build the models because, maybe Grok XAI's model has fewer guardrails on certain topics versus maybe Google's model has more guardrails on certain. So I think it's still a reflection of the people in those companies and what decisions they're actively taking for these models to output. Yeah, I'm not sure if we'll have a future where these models develop their own personality. I mean, that could happen. That could very well happen if you have some sort of. I mean, you've kind of seen that happen with. I forget what was the name of that Microsoft agent that was released back in the early 2000s, where they released it to Twitter before XAI. So they released it to Twitter, and then it very quickly became spewing a lot of hatred and a lot of bad things. So, but I would say that is still a mimicry of all the bad content that humans sort of put out on the internet, and it sort of learned its quote quote personality from that interaction. Identity is, I think, it's a very philosophical question. I'm not sure from my perspective these models have identity per se.
They have, yeah. Should they have it according to you, or it doesn't matter? They're just a token prediction machine.
Yeah, I mean, I think LLMs or AI, agentic AI, whatever, I think their use case right now is more to help humans in their tasks, or if there are repetitive tasks, we don't, we just give it to an agent. So I don't think that is an area that per se I should invest in or people should invest in right now as AI gets much more advanced and has more thinking capabilities, that then you need to think about these things more seriously.
Got it.
And I think it ties very closely to safety and guardrails on is it developing tendencies that are narcissist or self-preservation is more important than human preservation, right? Then these philosophical aspects need to be somehow handled in the model. But if you're just thinking about, you know, day-to-day tasks, it's less of a use case or yeah, less of a weight.
Got it. Last question, but this is from my curiosity point of view, and I don't have a tech background, so bear with me here.
Yeah.
This whole psychological security part of the model, right? The way when you tell them, "Are you sure about it?" Some say yes, and some say no. Even when they were right, this whole
Hmm.
psychological security, does this happen during the fine tuning stage, or what is the stage where this gets determined?
So I just want to understand that question. So when you say, let's say you ask the question, the LLM responded, and then you ask it, are you sure about this answer? Are you talking about that interaction, that kind of interaction? Like how does the model come up with that?
Yeah, when you challenge it, the way it feels secure with its answer or insecure and goes back to, saying, okay, I'm sorry, apologizing, that behavior, what
Hmm.
part of the training does this get formed?
Yeah, it's probably more in the instruction following or fine tuning part where, and guardrails part, right? So you can make it to be more apologetic sounding. So how do you make it sound more apologetic is you can fine tune it on that sort of interaction data. Or you could, if you're doing RLHF, you could say that, you need to, if the user challenges your question or your answers, they maybe be more apologetic. So that kind of, yeah, just by next token prediction, it might have learned if those kind of interactions happen on the internet. I'm sure in the comment section and these kind of things happen. So the LLMs can learn from that. But how the sort of tonality of your response depends on the instruction fine tuning step. Yeah, that's where the models get it from mostly.
Then these frontier labs have so much responsibility, right? It's like everyone's just constantly agreeing to someone, then
Yeah,
this whole point of psychosis versus if someone's always challenging you, also you would get frustrated and leave them on it. So that's
yeah.
such a
It's a pretty hard problem. I mean, it's fascinating how they've been able to solve it at scale. That too. I mean, uh, yeah, I don't think individual researchers can do this. You need like a team of people, to think about these ideas very deeply. Yeah.
Is there anything else from your end, like basis everything we've spoken, basis your experience in OR, like how things are moving? Any closing thoughts?
Yeah, I think I'm most fascinated by the continual learning paradigm that some, AI labs or academia is exploring, because that would mean we don't need to build these giant models and consume so much power building them. Maybe you can build smaller models and get much better reasoning capabilities and thinking capabilities. So that is a fascinating area of research for me. And then I just think, yeah, at some point, people have to do more in connecting causal reasoning with deep learning. I think that's a open area of research that not many people think about today. Um, so yeah, those are some of the topics I'm the most fascinated by.
Who's doing some really good work in like continual learning? If I want to like study it further or understand it further from the
Yeah, there's a research lab in Japan actually, started by I think one of the founders was the core contributor and author on the Transformers paper. So they started their research lab in Japan, and they are trying some interesting work on continual learning. I know in Europe this year there were some other papers. Europe is also pretty big, so I didn't attend it, but I've heard there were some interesting papers on continual learning on that space as well.
I was expecting US, but like you've told me two different geographies that I wouldn't have related to continual
Yeah,
learning.
so I read that paper. That it was the most interesting paper I read, so that's why I brought them up. I mean, yeah, they have researchers from all over the world working in Japan for their research lab. But yeah, I'm sure every academic institution in the US and across the world is going to now think about these ideas because that is probably the next wave. Yeah,
Yeah, and we're falling short of compute. I mean, resources at some point will get strained, right? And
yeah,
people then have to make trade-offs between fresh water for humans and fresh water for data centers. And you want to solve this
yeah.
problem before it comes to that.
Yeah, and I just think from our own like human brains, we don't need a data center worth of power to do all of these reasoning tasks, motor skills, yeah, just creative thinking. So there is something missing. We are, if we want to, even I would say replicate human level intelligence, not just build a new kind of intelligence. This is my opinion that something else will help us get there, not just scaling large language models. I think scaling is really helpful, and it's remarkable what we've been able to achieve so far with scaling. But I think scaling alone, the model size is not going to. achieve as the next or human level intelligence that people are seeking.
Yeah, I mean, it got us this far, but what takes us to the next leap is something altogether different. That's what you're also trying to say, right?
Correct. Yeah. I think there are elements of the human brains that we need to invent and codify into equations or whatever models that we can leverage, and those components are missing somewhere. Yeah.
Thank you so much. This was really helpful.